So now we're going to look at certain types of rate problems. And what's happening in these rate problems is we're analyzing a population of people. And in each problem, we're comparing the population to another value. So the first type of problem we're going to look at is a population density problem. And what we do in population density is we compare a population of people or population of animals or a population of objects to a specific piece of land. So population density is a special type of rate. It compares the number of people per land area. This example says, the state of New Jersey spans across 8,729 square miles, with a population of 8.91 million people. Determine the population density. So for this problem, it makes sense to take this rate and convert it to a unit rate. So I'm going to divide the numbers. And the reason why it makes sense to convert it to a unit rate is because it might be useful for me to determine, based on what I'm being told here, how many people can I expect to be located within just 1 square mile. If I want to compare it to 1 square mile, I have to determine the unit rate because that's how a unit rate is defined. Remember, you compare a value to just 1 unit. So I'm going to set up my division. So I said that we're going to compare the number of people to the land area. And this is a type of problem where you can't necessarily divide in any order. Because if you try dividing in the opposite order, conceptually, it just doesn't make sense. For example, if you try dividing land area by people, you'll end up with a certain number of square miles per person. And that just conceptually doesn't make any sense. That's not telling me anything. What would be helpful is if I have a certain number of people per square mile. That is useful information. So I'm going to determine people per square mile, which means I'm going to divide people by square miles. And one thing I'm actually going to do is I'm going to first convert 8.91 million into standard form. The reason is, I'll show you, is if I leave 8.91 the way it is, I'm just going to end up with a really small decimal because I'll be dividing a really small number by a really large number, and that really small decimal might not be able to tell me much. It might not be useful to me. So I'm going to convert this to standard form, and to do that, I'll have to multiply 8.91 times a million. So using your calculator, 8.91 times 1 million is 8,910,000. So 8,910,000 people. I'm going to make sure to express my units over 8,729 square miles. Let me just make this bigger. Sorry. Okay, so I'm going to go ahead and divide my numbers. Divide by 8,729. So I get a decimal, right? Again, I'm not going to leave it in decimal form because I am referring to people, and you can't have a decimal amount of people. And what I'm actually going to do here is I'm not going to round up. So usually if you were going to round this number, you would round it up. But I'm going to leave it as 1,020 because this decimal doesn't represent a full person. So I just have 1,020 full people. So that makes more sense to use. rather than 1,021. So I'm going to use the number 1,020. 1,020 is the same as 1,020 over 1. So 1,020 people over 1 square mile. So based on this information, I know that in the state of New Jersey, there's 1,020 people per square mile. And that's helpful because that tells me how populated the region is. Let me just push this back. There you go. Okay, so let's look at more types of rate problems that refer to population. So in this example, we're seeing that it says in a given year, a region had a population of 942,721 people and 21,452 births. Determine the birth rate. So what we're doing here is we're comparing population, but this time we're comparing population to number of births rather than comparing population to a piece of land like we did before. So first thing I have to ask myself is, what do I want my final answer to look like? Because if I know how I want my final answer to look like, then I'll know what order I want to divide in. So if you think about this, it would make sense if we knew the number of births per person. What doesn't make as much sense is the number of people per birth. If I told you there's 50 people for every birth, how is that really helping you to analyze the birth rate? That conceptually, that's not as helpful. So I know that I don't want my final answer to look like this because that's not going to tell me much about these numbers. What I want my final answer to tell me is how many births are occurring for every single person in this region. So now that I know that my final answer should say number of births per person, that tells me the order to divide in. So I'm going to divide the number of births by the number of people. So there's 23,452 births, 942,721 people. Okay, so let's see what it looks like when we divide the numbers. So let's see what it looks like as a unit rate. If you divide 23,452 by 942,721, all right, we get a really small decimal. I'm not going to use that many digits. I'm going to use the first two. So I'll use 0.02. .02 births per one person. So I have my unit rate, but the thing is that this is still not really helpful information because of this number. So this is a really small decimal, and conceptually this doesn't make sense since I'm talking about number of births, and it's impossible to have 0.02 births, right? So for this type of problem, the unit rate might not be the best rate to do. So what you can do if you encounter a situation like this is you can convert this ratio to a ratio that is a more understandable by multiplying both numbers by 10 or 100 or 1,000. For example, if I try multiplying 0.02 by 10, And I do the same to the denominator. Let's say I multiply 1 by 10. So now I would say 0.2 births per 10 people. That's still not that helpful to me because, again, this doesn't make any sense. What do you mean there's 0.2 births? That's impossible. So what I'm going to do instead is I'll try multiplying this time by 100. So when I multiply 0.02 by 100, I get 2. When I multiply 1 by 100, I get 100. This now makes much more sense to me. Now that I'm seeing for every 100 people in this region, there were 2 births. This would be the best rate to use to summarize this information. So what we basically did was we took our original rate, we converted it to a unit rate, and then we converted that unit rate to an equivalent rate. This is still an equivalent rate, but we just multiplied by the same number in the top and the bottom to take this out of decimal form. We didn't want this to be in decimal form because in decimal form, it doesn't make sense since we're talking about births. So now this makes a lot more sense. Now I can basically say there are 2 births for every 100 people in this region. So let's look at one more population rate problem. This problem says there are 3 supermarkets in Norwood, Bronx. This neighborhood has a population of 40,000 people. Calculate a unit rate for this scenario. So again, we're looking at population of people, but this time we're comparing population to resources that are provided to those people. And the resources we're referring to are supermarkets. So we want to determine a unit rate, right? Again, the first thing we have to ask ourselves is what do we want our final answer to look like? Because if we know what our final answer should look like, that will tell us the order we should divide in. So there are 2 possibilities. We could have the number of supermarkets per person, or we could have the number of people per supermarket. So this, off the bat, I'll tell you right away that this doesn't make as much sense. And I'll show you why when we look at the numbers. This conceptually doesn't help me. If I told you there's 5 supermarkets for every person in this neighborhood, how is that useful information when I'm thinking about the resources that are being provided to the people in this neighborhood? So what if there's 5 supermarkets per person? But if I tell you that there's 100 people per supermarket, that's much more useful to me if I'm trying to analyze this neighborhood and the resources provided in this neighborhood. So let's say I were to do the division. Number of supermarkets, there are 3 supermarkets for 40,000 people. Let's say I divided it this way. The first issue is that I'm going to have a really small decimal because I'm dividing a really small number by a really big number. So I have 0.000075. .0000075 supermarkets for 1 person. Like I said before, this is not useful information. Okay, so you're telling me there's 0.000075 supermarkets for every person in this region. That's not going to help me, which tells me that this is not the order I want it divided in. So I'm going to divide the number of people by the number of supermarkets. 40,000 people by 3 supermarkets. When you divide 40,000 by 3, you get a long decimal. Again, I'm not going to use a decimal portion because I'm talking about people here. And I'm not going to round up because this decimal portion would not create one full person. So I'm going to leave it as 13,333. 13,333 people for one supermarket. So this makes a lot more sense because this is basically telling me there's not enough supermarkets in this neighborhood. This is a lot of people for one supermarket to have to serve. 13,333 people are all expected to shop from the same supermarket. So this is useful because this might tell the politicians in this neighborhood that they need to create initiatives to construct more supermarkets in this region.